Hey guys, welcome back. I hope all of you are doing well. It's been a while I've posted any video, but from now onwards I'll be starting your air navigation series in which I'll gonna cover all the theory parts and numerical from your general navigation, instrument navigation and radio navigation. Soon I'll be posting videos for air metrology, regulations and technical journal. I hope these video will gonna help you clear your DGC exams. So without any further delays, let's get started. So now first we'll cover your first chapter, that is solar system. So now what is solar system? In Hindi we call it as Saur Mandal, right? In simple terms, solar system is the gravitational bound system of the sun and the objects around it. Objects like Mercury, Venus, Earth and all the other planets and stars. And sun is the center of our solar system and all other planets and stars orbits around it due to its gravitational force, and Earth is one of the planet in our solar system which follows an elliptical path around the sun. So now what is this elliptical path? Elliptical path is kind of elongated circle, or you can say an oval shaped design which is not look like a perfect circle. The Earth's orbit around the sun is elliptical, meaning it's not perfect circle but rather an oval shape. So not only Earth but all of the planets in our solar system follows this elliptical path, and it look like this path. Okay, and each planet takes 1 year to complete the orbit around the sun, and the planets are positioned at different distance from the sun and they are traveling at the different speeds through the space. So each planet years is different. The Earth years is equivalent to 365 days, 5 hours, 48 minutes and 45 seconds. And guys, always remember one thing: all the planets, stars present in our solar system like Saturn, Jupiter, all the stars and planet rises from the east. Okay, so now we have covered what is solar system. Now we'll come on Kepler's law of planetary motion. So what is this Kepler's law of planetary motion? First we have two laws. Now we'll look at the first. Each planet follows an elliptical path with the sun at one of the foci. The sun can be at any of the foci. It can be here or it can be here. I have already told you about the elliptical path. Due to this elliptical path, the distance between the sun and our planet Earth always varies. Suppose this is our planet Earth. Sometimes they are very near, sometimes they are very far. This is what first law says. Now we're gonna come on the second law. Kepler's second law says a line joining a planet to the sun sweeps out equal areas during equal intervals of time. This means that a planet will move faster when it's closer to the sun and slower when it is farther away. Earth is covering this area 2 and area 1 in equal interval of time, that is 1 month. Earth is moving slower when covering this area, and it is moving much more faster when covering this area. This is what second law says. Now I hope all of you guys understood about Kepler's first and second law. Now guys, we all know Earth is revolving around the sun in any space or in any area, and that space or area we call it is as celestial sphere. Okay, all heavenly bodies like sun, planets, stars appear to be located on a huge sphere, and this imaginary sphere is known as celestial sphere. Let's imagine this gray circle is our celestial sphere. Okay, and Earth is at the center, and we cut Earth into two equal parts. The plane that cut Earth into two equal parts, this bluish region, we name it as celestial equator, and sun is somewhere here and following this green elliptic path. Now sun is revolving around the sun, we are just imagining it. Okay, and the angle between this celestial equator and this green line which the sun is following is 23.5 degrees. Okay, and this angle is also known as obliquity of ecliptic. Okay, and guys, our Earth is tilted, and it is tilted around 23.5 degree. So we have two poles. First is north celestial pole and second is north elliptic pole. And the angle between these two poles is also 23.5 degree. These two poles are just imaginary poles in our celestial sphere. Okay, you guys just remember Earth is tilted from its original axis. Okay, suppose this is our original axis, but Earth is tilted like this from its original axis, and this angle is 23.5 degrees. And because of this tilt, seasons are formed. This was supposed to be our original Earth's rotational axis, but because of the tilt, because of this 23.5 degree tilt, the whole game changed. The seasons are formed. If this tilt isn't there now, there would be no seasons, there would be no summer, no winter, because the sun's position relative to our equator doesn't change. I'll teach you more about this in some time in this video only. 3 different factor causes 3 different things. First is seasons, third is years, second is years, and third is day and night. Season happens because of tilt, years because of revolution, Earth's revolution around the sun, and day and night happens because of rotation, Earth's rotation. First, we'll go through the seasons. We all know we go through different seasons throughout the year, and these seasons happens because of the Earth position with respect to the sun. First, we'll talk about when Earth is closest to the sun. When Earth is closest to the sun, we call it as perihelion, and it happens on 3rd of January. So some of you guys might think or might have doubt in this. We are getting more density of sun rays because Earth is close to the sun, so there should be a summer. गर्मी होनी चाहिए यार, ठंड क्यों है? So this happens because of one reason यार, Earth's tilt. Because of Earth's tilt from its axis, and the tilt is 23.5 degree. Yes, Earth is nearer to the sun, but it is like this. So southern hemisphere is getting more density of sun rays, and northern hemisphere is getting less density of sun rays. So that's why there is a winter in the northern hemisphere and summer in the southern hemisphere around January and February and December. I hope you guys got this concept of tilt. So there will be winter in India because India lies in the northern hemisphere, and summer in Australia because Australia lies in the southern hemisphere around this time, January, February and December. Now I hope you guys understood the concept of winter, and just opposite happens in summer when Earth is farthest from the sun. As you can see, this northern hemisphere is facing, this part is facing directly towards the sun, so we are getting more densities of sun rays in northern hemisphere. That's why we are having summer at this time around, and we call this period aphelion, and this occurs on 3rd of July. Now we know summer and winters are not dependent between the distance between Earth and sun. It depends on the which hemisphere is facing directly towards the sun. At perihelion, the southern hemisphere is facing directly towards the sun, so there is summer in the southern hemisphere and winter in the northern hemisphere. And at aphelion, northern hemisphere is facing directly towards the sun, so there will be summer in the northern hemisphere and winter in the southern hemisphere. चलो यार, ये जो tilt है ना, 23.5 डिग्री tilt, जिसकी वजह से ये सब हो रहा है, समर विंटर्स हो रहे हैं, इसको एक दूसरी फॉर्म में समझते हैं. So this is our Earth, and this solid line, this solid black line is our equator, and these dotted lines are Tropic of Cancer and Tropic of Capricorn, and these both lines are 23.5 degree apart from equator. Equator is at 0 degree, and these lines are 23.5 degree apart. This is our Tropic of Cancer, and this dotted line is our Tropic of Capricorn. We know sun rises from the east, so sun is coming like this. First, it goes to 23.5 degrees south latitude in southern hemisphere, and this period we call it is as perihelion, occurs on 3rd of January. So there is winter in the northern hemisphere and summer in the southern hemisphere. Then it goes like this and comes to equator. Now you guys should know one term, equinox. Equinox means when day and nights are equal. So when sun is at the equator, the day and night are equal. And when it crosses equator, it goes like this to the northern hemisphere till 23.5 degree north, Tropic of Cancer, and this period we call it is as aphelion, occurs on 3rd of July. So there is summer in the in the northern hemisphere and winter in the southern hemisphere, and again it comes like this, and this cycle goes on. This is how summer and winter happens, and how the movement of sun throughout the year. And sun crosses equator twice a year, and this happens on 21st March and 23 of September. We call it is as spring equinox and winter equinox. And these are the period when day and night are equal. Now we'll talk about solstice. So what does this solstice word means? It means when sun is at the highest point or latitude in any hemisphere. We know sun can go till 23.5 degree in any hemisphere. So sun can be here or it can be here. When we talk about winter solstice, it means sun is at the highest point in southern hemisphere. So sun is at 23.5 degree in southern hemisphere. And when we talk about summer solstice, it means sun is at the highest point in northern hemisphere. So sun is at 23.5 degree north at Tropic of Cancer. Winter solstice occurs on 21st of December. It means winter in the northern hemisphere and summer in the southern hemisphere. And summer solstice occurs on 21st of June. It means summer in the southern hemisphere and winter in the northern hemisphere. Now I hope you guys got the concept of seasonal variation, why summer and winter occurs, and things about equinox and solstice. And guys, do remember these dates, because there might be any question related to dates can be asked in exam, and the whole concept is very important for exam. I'm sure there will be 1 or 2 question will be in exam related to this seasonal variational topic. Some theory stuff. Season: Earth revolves in its orbit around the sun in 365 days. Earth axis is inclined at an angle of 66.5 to elliptic and 23.5 to the axis. Now day and night. We all know day and night happen because of the rotation of Earth around its own axis, and for the one complete rotation we call it is as a one day. Formed due to Earth rotates on its axis from west to east. When viewed from above the North Pole, this rotation appears counterclockwise. Earth completes one rotation in 24 hours. Now we have 3 types of days. First is sidereal day, measured from a star. The periods between successive transits of star over a particular meridian. It is approximately 23 hours 56 minutes. Apparent solar day, measured from real sun. Due to Kepler's second law, the speed of Earth around the ecliptic varies as the distance from the sun varies. This is why the apparent solar day will not be constant value. Length varies from 23 hour 44 minute to 24 hour 14 minute. Max difference is 16 minute in November and February. You just have to remember the time frame. Mean solar day. Mean sun is an imaginary sun which revolves around the earth at uniform speed, which is average speed of the sun. So mean solar day is interval between 2 successive transits of mean sun over a particular meridian. It has exact 24 hours. Apparent solar day is smaller or longer than mean solar day. As you can see, mean solar day has highest time frame among these, and our normal days are also mean solar day. You just have to remember the terms and time, because these are not that significant, but you should remember the time. Now we have one more term related to time, that is equation of time. True sun will sometimes be ahead and sometimes behind. Max difference is 16 minutes in November and February, and this is known as E of T. Just remember it. Now we come on years. For years we have two type of years. First is sidereal and second is tropical. Sidereal, it is the period between two successive transits of Earth, Sun and a fixed point in space, that is a star. It is equal to 365 days, 6 hours and 9 minutes. Tropical year, it is the period between two successive transits of the Earth, Sun and the Eris. So length of tropical year is 365 days, 5 hours and 49 minutes. Tropical year is shorter than sidereal year by 20 minutes, and civil year has exact number of days and is based on tropical year. Civil year is the year we follows, and civil year, our regular year, has exact 365 days, 5 hours and 49 minutes, same as tropical year. And our regular year is same as tropical year, that is 365 days, 5 hours and 49 minutes. For our reference, we know we celebrate New Year when Earth completes a rotation of 365 days around the Sun, right? But in real time it is equal to 365 days, 5 hours, 48 minutes and 45 seconds. But for our calendar references, the civil year has 365 days, 5 hours and 49 minutes that we have studied. So to compensate this 15 seconds, we take every 4th year a leap year. Means we add one more day to our calendar, that is 29th of Feb, and that year we call it is as a leap year and has 366 days. Okay, and now here comes the topic Twilight. It is the very interesting topic and the last topic for our video. Before sunrise there is a period when it becomes light, and after sunset there is a period when it remains light. These are called twilight. In simple terms, sun is set but still we can see the light, or the transition between day to night. It look like this. This period we call it is as a twilight period. This period. Now why does it happen? We all know our Earth is having a very dense atmosphere, right? Where all the gases are present like nitrogen, oxygen, carbon and all other gases. So due to this dense atmosphere, scattering of light and refraction occurs. Means when light is coming from a star or any object and it reaches to our eyes, but due to our dense atmosphere it gets bent here, and we see the object somewhere else due to this bending, regardless of the actual position. So we see the object here, but it is actually here. And same happens in twilight. As sun goes down below the horizon, due to the bending of light, we can see the sun for some more time. So this is our Earth's surface and this is our horizon. So when sun is set, sun is already set, sun is here, but due to the bending, when sunlight is coming like this, and due to the bending we can see the sun here. So we can see the sun for some more time, but in actual time it is already set, and it happens because of the atmosphere, because of the bending of light. And this is why twilight happens, and this happens because of our dense atmosphere. This is how it looks like in real time. So due to the bending or refraction, we see the apparent position of the sun, but the actual sun is already set. And this thing is also dependent on observer's height. If you are standing on the tall building, you can see the sun for some more time. For example, you are standing in park and your friend is standing on some building of height 1000 feet. so your friend can see sun rays for longer period of time compared to you. And this is the concept of twilight. Just remember, twilight period is of 21 minutes, and suppose you are standing on equator, you will get a twilight period of 21 minutes. And your friend is standing on the north pole, he'll get a more period of twilight, or there will be a time when sun is at northern hemisphere, so he can only see days for 6 months, and vice versa, because with the increase in latitude the twilight period also increases. Now we have three types of twilight period. First is civil, nautical and astronomical. And there is one more thing, sensible and visible horizon. So what is sensible horizon? Horizon which is visible to our naked eyes regardless of any atmospheric refraction, that is sensible horizon. And sensible horizon is above visible horizon, and visual horizon and visible horizon are the same thing. And twilight period is related to the sun center being below the sensible horizon, and the center of the sun is approximately 50 minutes of arc below the sensible horizon. Okay, now comes the visual horizon. When we cater for atmospheric refraction, which causes an observer can see object which is actually below his sensible horizon, and that horizon we call it is as visual horizon. Sunset and sunrise time are taken based on sun's upper lip or top of the sun being visible at horizon. Okay, I hope you got these two types of horizon, sensible or visible horizon. Now comes the twilight. First we have the civil twilight, which we use in our flying, and that is when sun is 0 to 6 degree below the sensible horizon. 0 to 6 degree. Okay, now nautical twilight. Nautical twilight happens when sun is below 6 to 12 degree below the sensible horizon. So this angle is 6 to 12 degree. Now astronomical twilight. It happens when sun is 12 to 18 degree below the sensible horizon. Guys, sorry for my handwriting, I know it's very bad. You just have to remember these terms. Civil twilight is when sun is 6 degree or less below the sensible horizon, 21 minutes near the equator. Nautical twilight is of 6 degree to 12 degree below the horizon and below the sensible horizon, and astronomical twilight is 12 to 18 degree below the sensible horizon. You just have to remember these number for examination, it might get asked. And for flying purposes, we only use civil twilight. That's all from the twilight. I hope you got the concept of twilight. Now we have some definitions. These definitions are not relevant to this chapter only, but in the next chapter. But for the next chapter, these definitions are very important. I just want you guys to remember these. Declination, it is the latitude of heavenly bodies. During the year, sun declination varies from 23.5 degree north to 23.5 degree south. R angle, it is the longitude of the heavenly bodies. It is the angle measured westwards from a particular meridian of the body. Remember, declination means latitude and R angle means longitude. Concept of latitude and longitude, I'll teach you this in our next video. Next video is about our earth. Local R angle when the measurement is made from the local observer's meridian. Greenwich R angle when the measurement is made with the respect of Greenwich meridian. And zenith, the point on celestial sphere directly above the observer. I hope you guys got all the concepts that I have teach you. If there is any doubt or any question, please let me know in the comment box, or you can direct reach me via mail. You can mail on my email ID. I have mentioned my email ID in the description of this video. And if you like the video, do remember to hit the like button and subscribe to the channel. We'll meet you in the next video. Till then, stay tuned, keep learning. Bye bye.